This AI-powered Raspberry Pi wrote a fully functioning Arduino sketch for my Arduino project, compiled it and uploaded it to the Arduino unit that is connected to this Raspberry Pi via USB without any kind of human intervention. That's it guys, I didn't provide anything other than providing a simple prompt. Let me show you how. This is the power of OpenClaw. It is a fully autonomous AI agent that can not only talk with you but also do things on your behalf. That means for my future project, all I have to do is set up the hardware and tell my Raspberry Pi to create and upload the code to Arduino for my project, and that's it. I don't have to write a single piece of code anymore. And you can do this as well in a few minutes. Let me show you how. I'll be giving you complete step-by-step instructions including the code and everything you need to build this one yourself. But the problem is, with great power comes great responsibilities. There are a few things that you need to keep in mind when you are setting up OpenClaw. Otherwise, you will end up in trouble. But don't worry guys, I'll be explaining everything in this tutorial video. So without wasting time, let's get started. So the first thing that we need is setting up the operating system for Raspberry Pi. And for this, we can go forward with Raspberry Pi OS, which is a lightweight OS for Raspberry Pi. And for a Raspberry Pi, this micro SD card will be the hard disk. So we will be first burning the image, the OS image in the micro SD card. And once it is done, we'll be inserting it back to the micro SD card slot and we can power it up. So if you have any doubts in setting up the OS, make sure you check out our previous video where we explain everything in a step-by-step manner. So watch that video and then come back to this. While we are setting this up, you will see a lot of commands that we will be executing in the terminal, but you don't have to worry. So first, let's SSH into our Raspberry Pi. If you already have a monitor, you can simply access the terminal and proceed. And the first thing we need to do is make sure the system is up to date. So simply run the command sudo apt update, and that will check for the updates in all the packages. Now once that is done, we would need to install a few packages that will be used during the installation process. So in order to do that, simply run this command. The main packages that we will be installing will be git, curl and build essentials. Most probably, you will already be having all these packages. Now, the most important part. OpenClaw requires Node.js version 22 or higher. But the problem is the default version in the Raspberry Pi OS repositories might be outdated. So, we install it directly from Node source. This command will add Node source repository for Node.js 24. And once this is done, we'll be using the command sudo apt install -y node.js to install the required version. So this process might take a few seconds, and once that is done, we can directly check the version of the node.js installed. Okay, so in our case, the version is version 24.14.1. So node.js is completed. Now all we need to do is install OpenClaw. But there is one thing that you need to make sure before going forward. If you are using a Raspberry Pi 4 or any Raspberry Pi version that has 2 GB or less than 2 GB RAM, you need to make sure that you increase the swap size. Without enough swap memory, the installation will freeze or crash, or even after installation, you will be facing some issues with the performance. So these commands that you will find in the description creates a dedicated 2 GB swap file, lock down its permission for security, format and activate it, make it permanent across reboot, and then finally reduce the swap units to 10, which tell Linux to avoid using the swap unless absolutely necessary. That will help us to protect our microSD card from excessive writes. Let me remind you, this step is very important. Now, once that is done, we can go ahead and install OpenClaw. So before going into setup, let me explain to you what exactly OpenClaw is, because it's not what exactly most people think. OpenClaw is not just a chatbot like ChatGPT or Claude, where you ask a question and it will give you an answer. This is a fully functioning, fully autonomous AI agent that can actually do things on your behalf. Yes, it can take real actions like writing files to your system or your Raspberry Pi, and it can execute terminal commands, upload code to our Arduino. It can browse the web from your system for more information. It can send WhatsApp or Telegram messages, and it can run so many things, which makes it amazingly powerful but at the same time dangerous if you don't configure it properly. And the good part for makers like us is OpenClaw is able to run in Raspberry Pi 4 or Raspberry Pi 5, which makes it amazing. We don't have to worry about the AI processing because the AI processing actually takes place in the cloud through an API. This single command downloads and runs the official OpenClaw installer. It detects our OS, installs the NPM packages, and sets everything up automatically. Now, let me tell you something. This process is going to take a while on a Raspberry Pi 4, even with the swap configured. I mean, we are talking about literally 15 to 20 minutes or sometimes up to 30 minutes. The SD card I/O is the bottleneck here. So in order to confirm that, if you open a second terminal and run top, you will see NPM actively using the CPU. That means it's working and it's not frozen. So just let it run in parallel and do not run Ctrl C or terminate the installation process. You can have a coffee and then come back. Okay, so once this step is completed, you should be able to see a warning regarding this path missing. So don't worry about that at the moment. We will be taking care of that in a few minutes once the whole process is completed. Alright. So once we have all the files and set up everything inside the Raspberry Pi, it will automatically start the onboarding process for OpenClaw. First, it will show you a security warning. And guys, please, you must read it. As I told you earlier, OpenClaw is a very powerful tool, and with great power comes great responsibilities. So you must make sure that the Raspberry Pi and the OpenClaw is configured in a very secure manner. Once you have read and understand the risk, you can simply select yes. And then you will be shown setup mode. We'll be having an option quick start and then we'll be having an option manual. But if you select manual, you will be having complete control over each and every aspect of our OpenClaw instance. If you select quick start, then it will be automatically applying some default configurations, and in the next step, you should be having an option to select the model provider. As you can see here, we have a lot of them, and for the time being, I'll be going forward with Anthropic. So we can select that, and in the next step, we will be having an option to select the authentication method. The easiest method of authentication would be using Anthropic API key. So before going forward, you need to have an account in Anthropic and you should be having an active API key. Also, you need to make sure that you have enough credit balance in the account. Otherwise, we won't be able to chat with the model once everything is set up. And then you can simply copy and paste the API key right here. Never share this key with anyone else. And once that is done, we can select the actual AI model from Anthropic. The default model will be selected as Anthropic Cloud Sonnet 4.6, but we will be changing it to Haiku 4.5. It is fast and not very expensive. And also for our purpose, this will be the best one in my opinion. Later if you want, you can of course upgrade to any higher model. In the next step, we can configure a new channel with which we can communicate with OpenClaw. This step is optional because we already have a web UI with which we can communicate with OpenClaw. But if you want, you can of course add an additional channel. And as you can see here, there are so many different channels available. We have Google Chat, Microsoft Teams, we have Telegram, we have a lot of them. So for the time being, the easiest one to configure would be Telegram. In order to configure this, you should have an active bot that you can create with BotFather, and you should be having the credentials with which we can send or receive message with that bot. It is called bot token. So once you have the bot token, we can simply select enter Telegram bot token, and in the next step, we can simply copy and paste the bot token right here. And later you can simply follow the setup process and provide whatever you want. If you want to configure or install new additional skills, we can do that right here. Skills are like additional tools or capabilities that you can give to our OpenClaw. And of course, we can do it later as well. So this process might take in total of around 5 or 10 minutes. But that actually depends on the options that you have provided or the skills that you have selected. So once this is done, you should be able to see a message like this: onboarding complete. But there is still one thing that we need to confirm. Now, if you scroll up a little bit, you should be able to see this control UI section, and there, if you try to access this URL from another browser from your laptop device, you might not be able to access it. There is one tiny thing that we need to do. First, we'll be running these two commands so that we'll be able to access OpenClaw from the terminal itself. So in order to confirm that this worked, we can check the version of OpenClaw using the command OpenClaw version. Now we need to make sure that the OpenClaw gateway is properly configured and is up and running. So in order to do that, we can simply run the command OpenClaw configure --section gateway. So once it loads up, we'll be seeing a question: where will the gateway run? So we'll be having an option to select local or remote. So we will need to make sure that this is set to local. And once you select that, we will be having an option to select the port. We can provide the default port, and in the next step, we need to select the bind mode. And here it's important that we select LAN. And then for gateway authentication, we can select token. And since we are not using tailscale, we can select off. And in the next option, we can automatically generate the token. Make sure you keep this token a secret, alright? I'll be using this token only for this demo purposes, and after that I'll be of course deleting this one. Once you have done that, you can simply run the command OpenClaw gateway start, and that will start the gateway. Now, there are two ways we can access OpenClaw dashboard. So first thing we need to do is run the command OpenClaw dashboard, and that will give you a set of instructions. So if you have a monitor connected, or if you already have some kind of graphical remote access, for example Raspberry Pi Connect, we should be able to simply open any browser from the Raspberry Pi itself and simply access this URL. And from here, we can directly start chatting. But make sure you have enough credit in the Anthropic account, because I was making a mistake right here because I was trying to initiate a chat by sending hello, and I was actually waiting for a response. But I was not receiving any kind of response. So I tried to stop this conversation, and I was trying to send another message asking which model am I talking to. And it took around half an hour to realize that there was no money in my account. The thing is, we need to put at least 5 USD in order to access Anthropic AI models using API key. So once I put the money, I tried to send the message once again, and I was properly receiving a response. Then I was asking it to create an Arduino code to blink an LED. And that actually returned a pretty good code. This one was fine, but what happened next was something amazing. So first I will close this remote desktop connection, and I will try to access it from my local laptop browser. From the output of the command OpenClaw dashboard that we ran earlier, you will see this no GUI detected open from your computer section. There you should be able to see an SSH command that you can simply run in our local machine, the local laptop, in another tab. This will create an SSH tunnel to the Raspberry Pi from our laptop. And with this tunnel, we should be able to easily access the OpenClaw UI directly from the laptop. We need to make sure that this window, this tab will be kept open. Now go back to this tab and simply open the URL with the token. Open a browser and try to access this URL. And there we have it. We have the console. You can navigate through the console, see all the metrics, see all the connections, the agents, the skills that we have installed, all the configurations, change the theme if you want. So basically customize everything. The next thing what I wanted to do was trying to make Raspberry Pi upload a code to Arduino with OpenClaw. And guys, before going forward, let me share with you something that might be really helpful for you. If you are really into electronics and robotics and home automation, then you know circuits and PCBs will always be a part of your life. And if you have been watching our videos, we have been using a tool called Altium PCB Designer for the past few years in order to draw circuit and create PCBs for our projects. Altium has so many beginner-friendly tools that helps us to draw the circuit and design the PCBs, whether it is for hobby projects or for professional use. We always prefer creating PCBs for our projects because it helps to keep the circuit clean and neat and helps to get rid of all the nasty wires hanging around. We can even see how the PCB actually looks like even before production in 3D in Altium PCB Designer. If you're a DIY electronics enthusiast, you're going to love it. So make sure you check it out. You will not regret it. The link is in the description down below. In order to do that, I was simply providing a prompt that explains how the Arduino board is connected to the Raspberry Pi, which pin is connected to the LED, and also the board model name. And I was telling him to create a code, compile it, and upload. And once everything is done, just let me know in the chat. And that's it, guys. I'm just going to hit enter and watch what happens. The OpenClaw is now checking if Arduino command line interface is installed, and it will be installing it if it is needed. Detecting the Arduino board on the USB port, then it will be writing the LED fade sketch, and then it will be compiling the code, and once the compiling is completed, it will attempt to upload the code to Arduino. Okay, the upload process has been completed, and if we look at the LED, we can see that it's fading. So this is amazing, right? We didn't have to write one single line of code. Everything was done automatically by OpenClaw with the help of Anthropic AI. Now I'll be swapping Arduino Uno R4 Minima with Arduino Uno R4 Wi-Fi. As you might have already guessed, this one has Wi-Fi capabilities, and we can host simple web pages with this Arduino Uno R4 Wi-Fi. Let's see if we can create a simple web server and host it in our local network with OpenClaw. And this is my prompt. Notice something clever here. I told it to use the same Wi-Fi network as the Pi. OpenClaw will actually read the Pi's network configuration to get the Wi-Fi credentials, and that's pretty impressive, right? And it's now reading the Pi's Wi-Fi configuration to get the SSID and password. But if the OpenClaw process doesn't have enough permission, it won't be able to fetch the Wi-Fi password. It will only be able to fetch the SSID. So if that's the case, it will ask for the password like it is asking me right now. So in the chat, we need to provide the actual password for the Wi-Fi network. And once that is provided, within minutes, it will set up the whole code that includes the Wi-Fi credentials, and then it will try to compile it and then upload it to Arduino Uno R4 Wi-Fi. Once the code is uploaded, it will make the Raspberry Pi scan the entire network, and it will find the IP address of the Arduino. And once it has the IP address, it will share with us a URL with which we can access the web server. Simply copy the URL, open up a new browser and paste the URL there and hit enter. And there we have it. This is the web page that is hosted in Arduino Uno R4 Wi-Fi. The best part is, once you set up the Telegram, you don't have to always access the UI in order to run all these commands and do all these actions. We can do this directly from the Telegram itself. This is amazing, right? But the thing is, we have only scratched the surface now. There are so many things that we can do with OpenClaw, Raspberry Pi, and an Arduino.